Hi everyone, we are working on lesson 12, which we are looking at chapter 2 in your MYP4 book, which is going to be talking about all the laws of the exponents or the laws of the indices. Alright, so we're going to start right off with looking at basically all the parts of an index and the bases and so forth. So if I have a raised to the power of m, the value of the a is called the base, and the value of the m is going to be called either the index, the exponent, or the power. So it's like saying a raised to the power of m. Okay, so what the laws of the exponents basically show us, are that we have different types of laws for the exponents. So the first law that we're going to take a look at is going to be the multiplication law. And basically what the multiplication law tells us is that if we have two bases that are the same, so an example of that would be base A here. Base A, there is base A in both of these exponents. There's a base A and a base A, and they have exponents m and n. Now, if I am multiplying two bases with different exponents, or two bases that are identical and they have exponents on them, then the multiplication process means that I'm going to be adding the exponents. So an example would be if I had a squared times a cubed, because I have the same base here, then that means, and they are multiplied, that means that I'm going to add together the exponents, so that I end up getting 2 plus 3 gives me 5. If I have x to the 5th times x squared, then it means that I have 5 plus 2 will go to 7. And if I have 4 to the 5th times 4 to the 6th, it's like me saying 4 to the 5 plus 6, which gives me 11. Now a further example would be something a little bit more complicated, like 6x cubed y to the 5th times x cubed y squared. So I would take the like bases, so x cubed and x cubed, and I know that it becomes x cubed times x cubed will go to 3 plus 3, which is x to the 6th, and y to the 5th times y squared will give me 5 plus 2, which gives me y to the 7th. And because 6 gets multiplied by a 1, really, that's in the front of that x cubed y squared, then it's 6 times 1, which equals 6. So my final answer there would be 6x to the 6th, y to the 7th. Alright, now, if the multiplication law tells us that when we have identical bases, when we multiply, we add the exponents, then the division law is going to tell us that if we have identical bases, then we're in division, that means that we are going to subtract our exponents. So for example, a to the 5th divided by a cubed would give me 5 minus 3, which gives us a to the power of 2. X to the 7th divided by x cubed gives us x to the power of 4. And then if we were to take a look at 12h to the power of 6 divided by 12h squared, well, h and h have the same bases, it's division, therefore I subtract my powers, or my exponents, so 6 minus 2 would take me to h to the power of 4, and 12 divided by 4 will take me to 3. Therefore my answer would be 3h to the 4th. If we take a look at this last example that we have here, so x cubed divided by x to the power of 1, so we have the same base, so 3 minus 1 gives us x squared, and then y to the 7th divided by y squared gives me 7 minus 2, which gives me y to the 5th. So that would be our division law. If we want to take a look at a third law, the third law would be the power to a power rule. So what the power to a power rule basically says is that if I have a power, a to the power of m, which is raised then to another power, n, then this would then, we would multiply our powers together, so you would have a to the mn. Now essentially, what is this telling me? It's telling me that if I had had a squared for example, 4 times, well, if I actually expanded this, it would become a squared times a squared times a squared times a squared. And when I have the same bases and they're multiplied together, then what that means is I am just going to add my exponents. So it would go to 2 plus 2 is 4 plus 2 is 6 plus 2 is 8. So it would go to a to the 8th. Now, it's easy to expand it this way when you are using smaller numbers. But if I had a to the power of 2 30 times, I'm certainly not going to write out a squared 30 times to then add them up together. So what I do is 2 times 30, which is a to the power of 60. All right, so an example then is a to the 5th all cubed will give me a to the 15th. X cubed to the power of 4 gives me x to the 12th. X squared to the power of 4 gives me x to the 8th. X to the 6th raised to the power of 5 times 3x squared. Well, I'm going to start that question by doing x to the power of 30, and then that gets multiplied by 3x squared. Now, the bases are the same. It's x and x, so it's 30 plus 2 will go to x to the power of 32, and then from there it will go to 3x to the power of 32. Same thing occurring in the next example, except with division. So if we did division in this case, then we would have x to the power of 28 divided by x to the power of 6, which gives us x to the 28 minus 6, which is equal to x to the 22nd power. Now, if we move on to the next example, we have another example here. Here's another law, which is where we have the same powers but different bases. So up till now we've looked at the same bases with different powers, in which we add together our powers or we subtract our powers together, depending on whether it's multiplication or division. And in this case, what we have is we've got different bases but same powers. So what the law is basically telling you is that if you were to have, for example, a to the m times b to the m, well, that's basically telling us that we've got the same power there of m. So I could actually multiply my two bases together and then raise them to the power of m. So that if I had xy raised to the power of 3, for example, that means that every term inside the parentheses would be raised to the power of 3, so that this would go to x cubed, y cubed, as an example. Now, if I had 2 to the 3rd times 3 to the 3rd, well, rather than do 2 to the 3rd gives me 8, and 3 to the 3rd gives me 27, in which case I'll get some answer. Okay, what I can actually do is I can say, well, what if I do 2 times 3 raised to the power of 3, which gives me 6 to the 3rd. And whatever 6 to the 3rd is, I'm not going to bother with it right now, but it'll be the same thing as 8 to the power of 27. Okay. So our next example then would be, again, also with division, where we have different bases, same exponents. So that a to the m divided by b to the m means that I could actually divide the two bases first and then raise them to the power of m. So the example I gave is 12 to the 4th divided by 3 to the 4th, which becomes 12 divided by 3, which is 4, which would then get raised to the power of 4. All right. Let's look at the next examples. The next examples are the ones with 0 and negative indices. So the law number 5 is anything raised to the power of 0 will always equal 1. So whether I have, as an example here on the side to the right, 2 to the power of 0 or 5x raised to the power of 0, for example, anything raised to the power of 0 will always go to 1. Now, if I did 8 squared divided by 8 squared, that's like saying 8 to the power of 2 minus 2, which gives me 8 to the power of 0. And 8 to the power of 0, again, is equal to 1. Now, if I were to do the next example, number 4 here, where I have 2x squared raised to the power of 0 divided by 2, well, anything raised to the power of 0 will always equal 1, and then 1 divided by 2 just means that I have 1/2. And 1/2 is the same thing as saying 0.5. So whether you write 1/2 or 0.5 is the same thing. Okay, my next law is one where I have negative exponents, because we have not dealt with negative exponents yet. So the next law says that if I have a base that is raised to a negative exponent, such as negative n, what I do is I take the reciprocal, or the opposite of that, so that I end up with 1 over a to the power of n. So if I have a to the negative n, to turn it into a positive exponent, it'll become 1 over a to the power divided by a to the n. So given an example, so I've got a few examples here that we could go over. Given an example such as 2 to the power of negative 3, well, that's really like saying 1 over 2 cubed. And 1 over 2 cubed is the same thing as saying 1/8. Now, if I did a squared divided by a to the 5th, well, 2 minus 5, I've got two bases that are identical. I subtract, because it's division, I subtract my exponents, so that I have a to the power of negative 3. Now, I never leave my answer as a negative number, so that it becomes 1 over a cubed. Now, if I have a to the negative 2 times a to the negative 5, it's as if I were doing a to the negative 2 minus negative 5, which ends up giving me a to the power of negative 2 plus 5, which equals a cubed. Okay, so that goes automatically to a positive. All right, now, let's do one more question here, because they start getting a little bit more difficult. So the next one that we're looking at is 4a to the negative 3b squared all over 2ab all squared cubed. So we're going to take this step by step, and I will say, well, the top is 4a to the negative 3b squared. I'm just going to leave it exactly the way it is for now. And in the denominator, I'm going to cube everything inside that parentheses. So 2 cubed will go to 8. A to the power of 1 cubed goes to a cubed, and b to the power of 2 cubed goes to b to the 6th. Remember, this is a power to a power rule, so everything gets multiplied. So it's 2 cubed, a to the power of 1, which goes cubed, so it's 1 times 3 is a cubed, and then b squared cubed is b to the 6th. So now I can simplify this, and I can say, well, 4 goes into 4 once, and 4 goes into 8 twice. Now I have a to the negative 3 minus 3, which gives me a to the negative 6, and I have the 2 underneath, so a to the negative 6 will be up at the top, and then b squared divided by b to the 6th gives me b to the negative 4. Now, in order to turn these into positives, I would have to bring them down to the bottom, so that it would be like saying 1 over a to the 6th, b to the 4th. And because that 2 is already underneath there, then it's 1 over 2a to the 6th, b to the 4th. Keep in mind that when we are doing these problems, if I have 2a to the negative 4, or 2x to the negative 4, the negative 4 exponent only belongs to the x. So that means that when I bring it down to use this rule of 1 over a to the n, then the answer would be 2 over x to the power of 4. It's like saying 2 times 1 over x to the 4th, and 2 times 1 over x to the 4th just gives us 2 over x to the 4th. Okay, the next one. We are basically done with the rules. All we're going to do now is we're going to do some practice questions. So let's start with a few practice questions, so that if I have a to the third, if I have a to the third times a to the power of 0, well, a to the third times a to the power of 0. A to the power of 0 is the same thing as saying 1, so that goes to a to the third. It's like a to the third times 1 is a to the third. If I have multiplication here, I've got a squared times a to the negative 5. I've got the same base, therefore I'm going to add together my exponents so that I have a to the negative 3. And when I turn that into a positive, I'm going to use this rule, that is 1 over, which is a to the negative n equals 1 over a to the n, which becomes 1 over a cubed. And if I do x to the power of 7 divided by x to the negative 5, I will get x to the 7 minus negative 5, which takes us to x to the 12th. And if I do a division here on number 4, x to the negative 2 divided by x to the negative 5, it goes to negative x. Oops. It goes to x to the negative 2 minus negative 5, which goes to x to the third power. And then our next one would be x to the negative 4. So it would be negative 4 minus negative 7, which gives us x to the 7 minus 4, which is cubed. And then our last example is on this side down here on the left, is x to the power of 0. Well, anything raised to the power of 0 will go to 1, and 1 raised to the power of negative 7 is like saying 1 over 1 to the 7th, which is nothing more than 1. If I do my next one, number 7, we've got x squared to the 4th. So here we have a power to a power in all of these examples, so that means that I will multiply all my powers together. So I have x to the 8th, y to the 4th, z to the 4th, divided by x to the 7th, y to the 7th, z to the 7th. So now I take my like bases, x to the 8th and x to the 7th, and I divide them. And in the division process, I subtract. So 8 minus 7 gives me x to the 1, or just x. Y to the 4th divided by y to the 7th gives me y to the negative 3. Z to the 4th divided by z to the 7th gives me z to the negative 3rd power as well. Now, because I do not want to have my answer is negatives, I'm going to end up having x to the power of 1, or just x, and that'll all be over y cubed z cubed, because again, I used the rule a to the negative n equals 1 over a to the n, so that y to the negative 3 is like saying 1 over y cubed, and z to the negative 3 is like saying 1 over z cubed. Okay, next question. We've got p, q, r squared all squared. So here, again, it's a power to a power. I will do p to the negative 2, q to the negative 2, r to the negative 4, and that'll be divided by p to the negative 10, r to the negative 10, q to the negative 5. And now I will just do the divisions, or subtractions in this case, of our exponents. So it would go to p to the negative 2 minus negative 10, and then it would be q to the negative 2 minus negative 5, and then it would be r to the negative 4 minus negative 10. And your answer here would go to p to the 8th, q to the 3rd, and then r to the 6th. All right. Last question. We'll do one more question here. Let's do a couple of more questions here on this page, and then we're done. So if I have 15 to the negative 4th power times 15 to the 8th, it's really like saying, it's really the same thing as saying 15 to the power of 4. Negative 4 plus 8 gives me positive 4. If I have negative 2, a, b, all to the 7th, all raised to the power of 3, then that gives me negative 2 times negative 2 times negative 2, which is negative 8, and it goes to a cubed, and then b to the 21st, all over, and a negative in the front here to the 5th power will always be a negative, so it's a to the 20th, b to the 10th. And now I'm going to simplify. In that, the negatives will cancel themselves out, so that I have 8 a cubed divided by a to the 20th gives me a to the negative 17. I can automatically take that a to the negative 17 down to the bottom so that the a to the negative 17 becomes a to the 17th positive. And then b to the power of 21 minus 10 will give me b to the 11th. And now the very last question, a to the negative 4th over b to the negative 5th. The only way I can simplify this is by flipping things around and making them both positives, the exponents. So I do that by bringing the negative 4, a to the negative 4 down to the bottom to turn it into a to the 4th, and b to the negative 5, I bring it up to the top to change it into b to the 5th. Alright, this is it for this lesson. I'm going to ask you to do the homework on this as well. Do your best, and we will continue this in class on Monday when you come in. We'll have a lot more practice and questions at that time.